Solve for w. And here we are given a radical equation. The square root of 11 times w minus 30 is equal to w. So notice here that within the square root, a w is trapped. So in order to start solving for w, we need to somehow remove the square root. So again, we have the square root of 11 times w minus 30 is equal to w. And so to remove the square root, we need to square both sides of the equation. So the square and the square root cancel each other out, and we are left now with 11w minus 30 is equal to w squared. Now recall that in order to solve an algebraic expression for the variable, we need to set the equation equal to 0. So I'm going to go ahead and bring all of the terms to the right-hand side. So to do that, I need to subtract 11w from both sides of the equation. We see 11w minus 11w cancels itself out to 0. And we're also going to add 30 to both sides of this equation. And we see 30 minus 30 cancels itself out to 0. And so this is leaving us with 0 is equal to w squared minus 11w plus 30. Beautiful! Now, I'm simply going to rewrite this as w squared minus 11w plus 30 is equal to 0 because I like to have my variables on the left-hand side. So in order to solve this quadratic equation, we're asking ourselves what two numbers multiply together to give us 30, but when we combine them together, we get negative 11. Minus 5 and minus 6. Woohoo! So we can rewrite this as w minus 5 times w minus 6 is equal to 0. And we can now think about each binomial case separately. We have w minus 5 is equal to 0, and we also have w minus 6 is equal to 0. So in case 1, to isolate w, we're going to add 5 to both sides of this equation. We see minus 5 plus 5 cancels itself out to 0, leaving us with w is equal to 5. And in case 2, to isolate w, we're going to add 6 to both sides of the equation. So minus 6 plus 6 cancels itself out to 0, leaving us with w is equal to 6. Now caution, before you box up this solution, we need to check. Right? We know that even root radicals have restrictions. So we need to check what we just found by substituting each w value into the original equation, which was the square root of 11w minus 30 is equal to w. So case number 1, let's think about when w is equal to 5. So this will become the square root of 11 times 5 minus 30, and we're asking ourselves, is that really equal to 5? I don't know, let's find out. So we have the square root of 55 minus 30, which is equal to the square root of 25, which we know is equal to 5. Woohoo! So that lets us know that w equals 5 is a solution. Now, similarly, we want to think about the case when w is equal to 6. So replacing the w in the original equation with 6, we have the square root of 11 times 6 minus 30, and we're asking ourselves, is this really equal to 6? So we can rewrite the left-hand side as 66 minus 30, which simplifies to the square root of 36, which we know is equal to 6. Woohoo! So this lets us know that w equals 6 is also a solution. So our beautiful final answer is that w can be equal to 5 and w can be equal to 6.